this is just about some strategy, some practical things and strategies that that we're currently using in conjunction with Cloud Functions. How many people here use Cloud Functions? We got a few. How many people here use Cloud Functions Gen 2? We got, this guy uses everything now, so that's fair. All right, so we're just going to touch on a little bit intro, some practical, how do you kind of work with Cloud Functions on your desktop before you deploy them. Some CI aspects, CD aspects, dependency resolution, another kind of a strategy about like different things to pack into a Cloud Function, and some other kind of details or nuances that we got into having to do with HTTP triggers and some of our networking details. So Cloud Functions, I always had sort of like there's a little bit of a challenge, like in my mind, how to like use Cloud Functions or like how to position Cloud Functions next to things like Kubernetes, and more recently things like Cloud Run, because there's like a spectrum of the ways you can use it. You can use each of those technologies to accomplish similar things, and there's slightly different characteristics around them. Historically, Cloud Functions and Lambdas suffered, or not, they didn't suffer, but they were sort of like positioned originally for things that didn't have like that had sort of lower latency requirements, like back-end things that were triggered in the background. But people liked them because they sort of removed this aspect of, well, as compared to something like Kubernetes, they removed this aspect of sort of that whole managing that whole layer of back-end infrastructure. So they were attractive in that way. But they did kind of suffer from like cold starts. Like if you hadn't called them for a while and you called them for the first time, they had to get launched and loaded into these back-end servers. And people came up with creative things to try to keep them alive, like these like background pingers that would ping them every so often to keep them warm. But more recently, the different like functions, I'll call them functions generally, DAS providers, like you know, all of the major cloud providers have this kind of a functionality. They came out with this way to like to keep them warm, like a minimum instances on Google Cloud Functions. And that sort of further blurred the lines between that and something like Kubernetes. That used to be like, oh, you know, we can't, you know, we need these things to like drive a website, and we need very fast response time when someone hits this like web page. We can't like we can't have an occasional, some of our end users wait 2 seconds, 3 seconds for a Lambda to get loaded, or for a, you know, for a Cloud Function to get loaded. So this like minimum instance thing sort of like blurred it and out, and now it like makes the choice like a little bit more nebulous. Like, why should we, you know, what are the strengths of something like Kubernetes compared to Cloud Functions? And then, you know, part of it was the programming model. So you had these sort of you had less control over the runtime, and the programming model was a little bit like prescriptive for Cloud Functions. But then enter things like, you know, Cloud Run, which is kind of like a Cloud Function, but it gives you a container to kind of like run this thing in. So it further kind of muddies the water, and we're sort of like entering into I think, you know, a different situation where yeah, I mean, things like, I guess like all that would be, left to consider are things that are maybe, what portion of this is cloud, when you're making that decision, should I run this stuff on GKE? Should I run it in a cloud function? Should I run it in maybe something like Cloud Run, or like how cloud agnostic is it? How proprietary is it? How much do I care about that little shim that's cloud specific or cloud provider specific? So anyway, that's just a little bit about cloud functions and functions as service and things like, I'll sort of like, I mean, I used to call them, or things like, I used to refer to it as scale from zero, because you could start off with 0 instances and then it would sort of like kind of crop them up. So you had 0, like, cost associated with when there was no traffic. But now with like min instances, it's like, it's not even scale from 0, because it's closer to a minimum instances. And so, I mean, it's good for us as developers because we have more choices, but it's bad for us as developers because we have more choices. Anyway, so a little bit about desktop testing. So like there's this thing called functions framework that you can use to sort of simulate a cloud function and environment on your desktop, which is great. Oh yeah, the thing I was, we were talking about, like, what part of this is cloud specific, what part of this is cloud agnostic, that the Knative is kind of this scale from 0 function, like spec, I guess, that's like it's is that like, it's like open, it's not like owned by a particular cloud provider, right? Like Knative, I know, originated at Google, Harry, but it's like, is it a CNCF thing now, or is it it's like open? Not sure. Okay. But anyway, so yeah, this function framework is somewhat agnostic. Like, it does come from Google, but it can be used in these different sort of contexts. So for cloud functions, for Cloud Run, for Knative generically, and for local development environments. So that's your friend for desktop testing before you get into CI/CD scenarios. And I think, like, it gets a little bit maybe overlooked sometimes with all this great stuff on the cloud, like but from a development perspective, like, you want kind of a quick turnaround to see if your code works or not. You don't want to have to deploy something into the cloud to see if it works, because that's a much longer development cycle. So you really kind of, sometimes it gets difficult with certain services, like something like, say, you take Composer or Airflow, it's like a lot more involved to try to run it locally and see if your stuff works, or think to simulate things like BigQuery. Maybe you can't really, sometimes there's not a great way to test something locally. So you kind of have to get into these scenarios where you're testing your code and you really do need to work with something remotely. Anyway, here's an example of, like, how you would work with functions framework. So you, like, say if you're working with Python, you install it like a regular Python dependency, and then you, like, in your cloud function code, you import it and you call it out as an annotation, and this thing hello is like your cloud function, and you can run it locally, like with this line here, just to kind of test it out locally before you shoot it off into whatever your CI/CD system is. And yeah, I think people maybe just like don't do that enough, I think, and sort of like, because if you kind of have to shoot it out to deploy it, to test it, it'll take a matter of minutes versus a matter of seconds. And if you're sort of have this like test cycles where you're like, if you're in the middle of testing something, you could have to test it, or mess around with it, trial and error with it, like dozens of times, and in an hour. And that kind of feedback loop, having a quick feedback loop can add up and make your work process more efficient. So continuous integration just generally is like, to testing before testing your stuff before you kind of deploy it out. And so like you can write things like this is sort of like a public service and PSA public service announcement about like, do your, do your tests, and you can have things like every language has its own like unit testing framework, and you can sort of like sometimes you have to factor your code in a way which lends itself to unit testing, and maybe sort of like shave some things are maybe a little bit harder than others. So like simulating web traffic is, a little bit harder to do in a test, but you could take sort of like just the logic and put it in sort of isolated functions that are easier to test in something like PyTest or JUnit or something like that. So that's always a good idea, whether you're doing cloud functions or anything else. Sometimes people get into new technology and they sort of maybe don't bring the sort of good practices from other things, like just because you're doing cloud functions and it's like kind of fast and it has these other benefits, like these little bite-sized things, doesn't mean you should like throw good testing policies to the or sort of like abandon other good practices. All right, so from a deployment perspective, there's a few ways to kind of deploy cloud functions. There's, it could be done with G-Cloud command line, and of course G-Cloud command line is really just like the stuff that runs on your at a command line, but it calls APIs. So like if you really wanted to kind of like get masochistic, you could call APIs directly. And then there's other things that sit on top of, there's other tooling like Terraform that could substitute in for G-Cloud, and Terraform has its own qualities and characteristics when compared to things like G-Cloud. Mostly is, or what I like about Terraform is that it can be declarative. So you can kind of define the current state of what you want your infrastructure to look like. And, these cloud functions they're sort of a blend. They're part infrastructure and they're part code. So they're a little bit of a special case as compared to using Terraform to deploy like a GCS bucket. Because you do have to deal with the code itself and push the code and sometimes zip the code up and, cobble together all the dependencies that are in the code and push them to a place that the cloud function can reference. So it's sort of like a special, I'd say, like more sophisticated, more complex case than deploying a GCS bucket with Terraform. So what we're currently doing is we use Jenkins, and so we use a combination of shell scripting and G-Cloud and Terraform to actually deploy a cloud function. So yeah, like we need to create zip files because cloud functions like to refer to zip files. We use like G-Cloud to move these zip files over to GCS so that they can be referenced by the cloud function. And then the Terraform itself, where you can define the cloud function and you kind of tell it where to find the zip file in the GCS bucket. So you have to kind of prep that. This is sort of like it goes in phases. So like I said, it's like a little bit of a involved deployment flow. So one thing that I noticed, like with Gen 1 cloud functions, and these are all about Gen 1 cloud functions currently, that if the when in Terraform, when you deploy a cloud function, you tell it where to find the zip file as a GCS object. If the name of that object doesn't change, the cloud function deployment doesn't think anything has changed. So it would not sort of like, it would not refresh itself with new code. So if you put new code out there in a spot, like in a zip file on a GCS bucket, and the name of that thing didn't change, the Cloud Function would think that nothing changed, so it would just continue running. Or in my experience, I found like I had to like come up with some strategy to make that the name of the archive that it referred to change. And I got into like, I was able to use the generation of the object on GCS as that, just sort of like as a, just sort of like a GUID or something to sort of like create a new bucket, a new object name, so that the Cloud Function would think or know that something has changed, so that it would sort of balance itself and pull in the new code. Dependency resolution. So like default, by default Cloud Functions, they are sort of like prepped up and positioned to resolve your dependencies for you. So like say if it's a Python-based Cloud Function, you would or could deploy a requirements.txt file with it, and it would pick that up and do the like pip install, like, you know, on the server side. And similar for, you know, different languages. All the different languages have subtle differences in the way their package managers work, but it's kind of the same concept. So like for us, like we run this thing through Jenkins, and in Jenkins, we pull all the dependencies locally to run our testing. So like there's like already this pip install type step running in Jenkins. And we also, those things that we pull, we can do security scanning on them to see if there are any like current CVEs on the versions of the dependencies that we're pulling. And we might be pulling dependencies from from one of our private PyPy repos, like we happen to use Nexus. And those things are not easily, or not sort of by default easily resolved. Well, so private dependencies are not easily resolved by the process, by the Cloud Function, by the backend Cloud Function process that GCP uses to do their pip install. So there's a strategy where you can you provide your, when you zip up the code associated with your Cloud Function, you can also zip up your dependencies and push those all your dependencies to this bucket for the Cloud Function to reference. And so like you don't, in that strategy, you don't provide a requirements.txt file to Google. You kind of like push all your dependencies, but there's a nuance there where the Cloud Function doesn't know exactly, like when you package up your dependencies, it's not in the exact default spot that the Cloud Function will look to resolve those dependencies. So there's this strategy, they call it like vendoring a dependency, and here's this little snippet of code that can be used to do that. So we like when we package up the dependencies that we've resolved over on the Jenkins side, we'll put them in a spot called packages. You can pick whatever folder you want, but you have to sort of like do this this voodoo on in your Cloud Function to tell that Python environment where to look to resolve those dependencies. So that's one thing. There's another nuance that could crop up having to do with subtle difference between the context in which you do the pip install on the Jenkins side and the runtime that you've selected for your Cloud Function. So we got, Dominique and I were working on this a few weeks ago, where we would we would build this stuff in Jenkins and resolve our dependencies and package them up and deploy them out to GCP. And then at runtime, there was sort of this dependency mismatch. And it turns out in this particular case that the version of Python that was running in Jenkins was a little bit off from the version of Python that was identified as the runtime for the cloud function. So that it was like ended up being like a Python version mismatch. So if you go do a pip install of, say, a package in Python 3.8, and then you do a pip, and then you're running in a runtime of Python 3.9, there could be, not always, but there could be situations that crop up with certain packages where they're not compatible. So we had to make sure that, like, when we did pip install over in Jenkins, that we were running the same version of Python that we selected as the runtime for the cloud function. And I think the same thing could potentially happen with certain packages also involve binaries, and those are the real sort of gnarly ones where compatibility can bite you. So you could get into situations where and this happens like a little bit, or if you can, so it's not just Python dependence, it's not just the Python version that affects dependencies, it could be the OS that affects dependencies. So if you could do a pip install and say, one version of Linux, and then you're running in another version of Linux, and it could pull a binary from the spot, a binary that's appropriate for the version of Linux that you did the pip install in, that might not be appropriate for the version of Linux that you're running in. So that's another gotcha. All right, so next sort of thing is like this other kind of a strategy, which may or may not appeal to everyone, but like cloud functions are intended to be functions, right? So you have like if you just have a single function and it's really doing something very isolated and specific, and it's kind of standalone, this really doesn't apply. So like but sometimes cloud functions and functions in general are used to kind of like create a larger system. And so you're not just kind of like your whole system isn't just like one function, it could be a dozen functions or more that sort of like that collaborate in different ways, kind of like when you say, I don't know, if you think about traditional like web API, like some kind of a Flask app or a Spring Boot app or an Express.js and Node app, usually you don't deploy those things out with just one endpoint. A lot of times you deploy them out with, it could be a few dozen endpoints, and you kind of think of that as a like a unit of deployment, like a microservice. In the cloud function space, like it becomes like more, it could, depending on the way your workflow is, it could be more of a, it could start to take up more effort to deploy out your system. So let's say your system is a dozen cloud functions, and you've made changes to all dozen of them, and now it's time to sort of roll it out somewhere. Now you're looking at a dozen different deployments. So there are some techniques you can use to sort of like deploy a cloud function and make it look more like something like a Flask application where it has more than one endpoint. Same thing with the other kinds of, like, you could do a similar thing in Node as well. So that's kind of a cool strategy. This link here kind of shows a blog post as to how to do that. And here, this is an example of the Python version of that. So there's like this, whoever came up with this was like pretty, I gotta say, a little bit creative, but the way it looks is you deploy your and I should say that this is only really relevant to HTTP based cloud functions. Like for things like a cloud function that gets triggered based on certain events, like based on a GCS event, like an object landing in a bucket or a message landing in a pub sub topic or something like that. That really doesn't apply. You don't have big applications associated with that. In the HTTP space, this is, a strategy that can be used. So like this is sort of Flask specific, but it basically creates a funnel between your request coming into your cloud function endpoint, and it sort of passes it along to a more full-featured Flask application. So this is like what your endpoint would look like, or your sort of entry point, and this is very generic. And then your Python app, the rest of your application could look like a traditional Flask app with different routes, like so. So that's kind of a, it could be something that might make sense for you, and depending on your requirements. And finally, this other aspect that we came into, having to do with HTTP triggered cloud functions and some of the nuances of the way GCP networking works. So like the symptom is we deploy a cloud function out, and our GCP has this this characteristic where things like rules and policies can be set at the high scale enterprise account level. And so we have like security people that do things like that, and they make decisions sometimes that actually thwart us as developers. But like, for instance, in this case, there's a policy that was introduced that said that cloud functions can only be deployed with the allow internal traffic only setting. So that applies this set of like network restrictions onto your cloud function. And so the symptom for us was we deployed an HTTP based cloud function, and now we want to call it from different spots, like maybe from like some GKE workload or something like that. Or maybe from a desktop just to see if it works. So like for me, like I deploy an HTTP based cloud function and I'm trying to call it from my desktop to see if it works. And no, it's not working. I'm getting like the 404, like I can't find it. And so like after some triaging and troubleshooting, so there's some other details to this too, is that like for allow internal traffic only, we also use shared VPC strategy which is like a way to like for large organizations to have like the control of the network in the control of like say a specific group or area in your organization that specializes in networks and network security. So they sort of run this network, and as a development or application team, they would give you small slices of network in the form of subnets. So they call that like shared VPC pattern. And there's like this there's like a centralized project that hosts the network, and then each of the application teams will be running in a different GCP project, and they'll call that like a service project. And the network guys will share off a little subnet to the service project. So for cloud functions, we use those little subnets to deploy these or to define these connectors, which allow us to run the cloud functions on those slices of shared network. So these are sort of like patterns that are sort of handed down or dictated to us from from out, like as a guy in a development group, these are patterns that are dictated to us from like the centralized network and security guys. So also VPC perimeters. So it's another networking thing, and it's like it's a pretty powerful pattern that that Google provides that allows you to define these virtual networks across groupings of projects, and there's other ways to configure and define what this sort of like a perimeter or boundary around a set of things like projects usually. And they're designed to like mitigate the risk of data exfiltration or DLP, data loss prevention. It's a DLP strategy. But so come to find out like that when you have internal traffic, when you have internal traffic only, you have this like shared VPC strategy, you have VPC perimeters in place, it starts to like narrow this the definition of what internal traffic is and means. And like one of the, and finally, there's this sort of like, I don't know, it's a little challenging little like bulleted list of what it really means. And this link here is actually, I don't think it's going to let me bounce out here because I'm only sharing the PowerPoint section right now. But it turns out like in order for your traffic to be considered internal only in conjunction with VPC perimeters and shared VPCs, that the host project has to be part of your VPC perimeter. But I asked the guys that manage the host project and they didn't want to put it in the VPC perimeter because they thought it would cause all sorts of other problems. So we're basically got like blocked on the ability to call these cloud functions in that setup and scenario. There's another like interesting nuance that I kind of learned about over the past few weeks, and that there's like multiple ways to call cloud functions. There is a way that you can call cloud function through Google provides client libraries for like a set of common programming languages that correspond to these different services. So for instance, there's like a Python library for cloud functions, and there's like a Node library for cloud functions. And these cloud function libraries allow you, they have an API that allows you to call into a cloud function. And this API that they provide actually like cuts through this. It actually did work to be able to call this HTTP based cloud function. It kind of cut through all of this like shared VPC perimeter stuff. And we were able to make it to work. It required separate IAM privileges to do that. But on further, research or reading the documentation and the fine print, this call was like, they say it's rate limited and it's only good for testing purposes. But that's actually the only way we could get it to the only successful call we could make was through this one that's rate limited. And that the actual, like the real way you're supposed to call it is through sort of like HTTP, like curl type situation with like an OAuth token that you get. And those, we couldn't get that to work. We kept on getting 404s. So like we have eyes towards Gen 2 because that has like supposedly improved networking, flexibility and characteristics. And so that's our next phase is to kind of look into Gen 2. We're currently have some Gen 2 is based on Cloud Run. And I guess like, I don't know, like right now, like we have this process by which we get different GCP services like approved for usage, and that Cloud Run is still in this like phase of getting looked at by the security guys and stuff. So that's kind of happening, but it's like, in progress. So, we're always seem to be in this, it's kind of a recurring theme where you're like in between, version -1 version and the +1 version, and they have slight, they're always making improvements, and we're trying to make these, we're always making these calls like, how much effort should we put on the older version of something, or how much, versus like, what's the risk of going with something that's maybe a little bit newer? Maybe it's like still in beta mode, maybe it just went GA, maybe you know, it's going to take all these modifications to our CI/CD strategy to migrate to it. And so that's kind of a recurring theme, but hey, that's the name of the game. Anyway, that's it for Cloud Functions. Any questions from, let's see, this will be interesting if there are any questions in the, oh wait, I see some stuff in the chat. See if I can do this. Oh, I'm gonna need my magnifying glass. These are, I don't see any questions here. All right, well, thanks for listening. And see you next time, next year, with Cloud Functions Gen 2.